Good evening, everyone, and welcome to Gresham College, and also to the people that I can't see downstairs, but I've already said hello to, and to online watchers and listeners later. Thank you very much for turning out on such a nasty evening. Tonight, what I want to talk about is air pollution, which is one of the most insidious challenges that bedevils all of us, environmental scientists included, this century. Tonight I'm not going to be talking particularly about greenhouse gases and climate change, at least not directly. That was a source of a subject of a lecture earlier this academic year, but about some of the other chemicals that human activity releases into the atmosphere and which we may then breathe, or which actually adversely affect ecosystems and the built environment. Now, the story of air pollution in the UK and elsewhere could be told as one of great success. So let's start with that. 70 years ago, there were some pretty major problems in some of our cities. I'm looking around the audience because I don't know how many people here are old enough to recall the London pea supers of the 1950s and earlier. I can't, I should say very quickly, but I can see there are at least one or two people indicating yes. You'll perhaps recall this sort of image. You'll know perhaps too that in 1956 the UK passed a Clean Air Act, and the burning of sulphurous wood and coal fires was banned in city areas. And since then, the visible black smoke has almost disappeared. In fact, those of you old enough to remember, and as I said, I don't remember, but apparently at the time there was a lot of opposition to the ban, because the issue was that domestic coal fires were seen as a powerful symbol of post-war British prosperity. They were about home and hearth. And today, I'm guessing today it's probably the size of the TV screen that fulfills the same function and designates your relative wealth and comfort. And both of those, of course, have environmental impacts themselves. But what you can see in the graph on the right-hand side is the additional 300 to 600 deaths per day in London that occurred over a period of days in the middle of December in 1952. Wind speeds were low, it was cold, so people were burning their fires, and open fires were very common in the capital. The other thing was that the coal-fired Bankside A power station, now the site of Tate Modern, was then dropping what was estimated to be 235 tonnes per square mile of grit just in the month of September. That was 1950, as measured by London County Council, as it was then. And that's probably not a coincidence that we had the smogs at the same time. And of course, those coal-fired power stations have almost disappeared in our cities. Just as an aside, of course, they haven't disappeared in the centre of some cities in the United States. I spent some time in West Virginia years ago, and there was a nice sulphur-rich coal-fired power station in the middle of the university town of West Virginia. So, a success perhaps there. And internationally, there have been some successes as well. Through the 1987 Montreal Protocol, for example, we have addressed the long-lived atmospheric chlorofluorocarbon emissions. CFCs is probably the shorthand version that people will know, coming from refrigerants, dry cleaning fluids, aerosols, and packaging materials, and those eroded a hole in the Antarctic ozone layer. Now, CFCs, and forgive me for those of you expert chemists, they are manufactured organic compounds, and they contain carbon, fluorine, and chlorine, which is often known in common parlance as the devil's element. These CFCs were often known by the DuPont brand name Freon, and you saw it on aerosols and so on. Now, the fact that stratospheric ozone protects humanity and other life from harmful incoming ultraviolet radiation had been known for decades, but its sudden depletion as a result of chemical interaction with CFCs, and actually involved nitrous oxide gases too, was only discovered in 1985 by 3 scientists from the British Antarctic Survey in Cambridge, Farman, Gardiner and Shanklin. Now, I'm going to show you a little piece of video here. As with many natural environment components, the Antarctic ozone hole swirls and pulsates, and I'll just ask you to watch this video. So we're looking at the Antarctic here. The blue is showing depleted levels of ozone, and here we see just what's happening on a daily basis throughout last year. So we're monitoring this from satellites. You can see the swirling and the pulsating of that hole. I like that. It looks like a flying sort of complex refrigerator, doesn't it? And here we see a longer-term image of the ozone hole. And again, you can see it's pulsating. It's occurring in slightly different position each year. And that difference, in fact, makes it pretty difficult to identify long-term trends. Now, originally, when our Antarctic Survey scientists reported this hole, or started looking at the data, or when other people had been looking at the data, the satellite observations which were being made at the time were assumed to be erroneous. They were assumed to be wrong. And so somebody carefully corrected them so that there wasn't a hole, because they thought this can't be right. And it was only when the Antarctic Survey scientists went out and did some ground truthing observations, actually checking on the ground, that the extent of the damage became apparent. They had to recalibrate the instruments. It's worth noting that the similar but less marked depletion of ozone also occurs over the northern hemisphere as well, but because there is more land mass over the northern hemisphere, it's not as marked, but it's there in the cold polar clouds above the Arctic too. Now, the scientists in that case were initially vilified by the sellers of CFCs, but despite that, an international ban nevertheless occurred very quickly indeed. There was some time required to develop replacement refrigerants and coolants, and there is still some CFC smuggling going on into developing countries, I understand. But the banning of their use has been a very good start, and I don't think any of us would say that CFCs were very much missed now. You can still have your hairspray, your deodorant, and so on without them. Nevertheless, the problem isn't entirely solved, because the hole is not expected to heal fully until 2060. And in fact, it had its largest extent ever in 2015 because of a volcanic eruption in Chile, which also put sort of CFC equivalents into the atmosphere. But the power of international negotiation towards a common goal was demonstrated despite the short-term economic cost. So that's a positive message. The lead researcher, Professor Susan Solomon, lead researcher at the moment in this area, who, alongside a group from Leeds University, actually, so Susan Solomon is from MIT in the States, there's a group from Leeds University involved as well, and she has some interesting messages about collaboration. She says that the precise message on collaboration is less than clear. On the pessimistic side, and I'm quoting her here there, it might be said that a modest-sized global environmental problem can be solved by the world, while a mega-sized one is another matter entirely. This was a chemical industry whose value was measured in billions of dollars, not the trillions that is tied up, for example, in climate change-related companies in the energy sector. But there's still some cause for optimism. We take here we see a picture of the Antarctic solar radiation in October 2015, the scientists taking observations there. And on the right-hand side, you can see there levels of some of the common CFC gases falling in the northern hemisphere. So there's some positive message. If we take another example, in the 1980s and 1990s, environmental researchers and even politicians in developed countries talked a great deal about acid rainfall. I'm sure most of you will have heard the language used. I've got my slides in slightly the wrong order here. Okay. Sulfur dioxide and nitrous oxides that had entered the atmosphere from industrial smokestacks and power stations and been washed from the atmosphere downwind by rain and snow, or had fallen as a kind of gentle shower of caustic dust. Now, even today, occasional rain and fog pH readings, and that's a measure of acidity, where low figures are more acid, pH figures of below 2.4 are reported in industrialised areas today. That's about the same level of acidity as undiluted Coca-Cola. Although I gather actually Pepsi is, I'm not taking money here, but Pepsi is slightly less acidic. But you'll know that what Coca-Cola does to your teeth. I've never tried it, but I'm told if you leave a tooth in a glass of Coca-Cola overnight, it won't be there in the morning. The point here is that the acidity created such excesses of hydrogen ions in soil and lakes that it killed the trees either directly or by allowing metals such as lead and mercury to be released into solution. Scandinavian forest and moorland ecosystems were very vulnerable and suffered from the UK's acid rain emissions. But from the 1980s, European protocols were developed requiring what's called scrubbing technology to be put into smokestacks, and it had demonstrable transboundary benefits to ecosystems and fish over the succeeding years. The reductions in the use of coal and in 2016, actually, coal provided less electricity in the UK than wind power for the first time ever. And actually, in May 2016, coal provided no electricity in the UK. But that reduction in coal, generally, is a more recent contributory factor. And the USA has had a somewhat similar experience following the legislation enforced by their Environmental Protection Agency. So, problems with trees, the sort of images you see here, this one's actually in the Czech Republic. We also know that sulfur dioxide emissions increased the erosion rate of materials in our historic buildings and monuments. At St Paul's Cathedral, for example, not far from here, investigations showed that exposed Portland limestone had often decayed to a powder under a thin and dirty skin of harder stone. Now, if we look at the erosion rates between 1710 and 1980, which was the really dirty period with all the smoke fires, the coal fires in London, London smogs and so on, the erosion rates on the balustrades of St Paul's Cathedral were roughly double what they are now. And these have been determined in all sorts of different ways by a research team which actually includes Sir Ron Cook, who used to be my tutor actually when I was an undergraduate. Surface erosion rates then have fallen, and sulfur dioxide levels have fallen dramatically over that period since the monitoring began. The active monitoring today started in 1980, and over that 30-year period, the erosion rates are at a significantly lower level than they were at the beginning of the period. You can just about see on the graph here, these are different decades, and you can see in some cases here the erosion rates on the balustrades, as measured, have dropped quite dramatically in that period. Okay, so that's another example of a success, if you like, an international success story for managing atmospheric pollution, in that case largely driven by the European Union. Despite the triumphs, and I could have talked, of course, about removing lead from vehicle fuel as well, there are some serious and insidious problems persisting. I put this wonderful map in because I couldn't resist putting it in, just to show you what London did look like in the early part of this, the period I was referring to a few minutes ago. This is actually 1550, and just point out that we're about here. So London was actually somewhere over to our east at that point, and so was St Paul's Cathedral, but not the same one, of course. Fabulous map. I just love maps, of course. Okay, now back to air pollution. There's still some serious problems. In last year, and I'll just stick to last year, in October 2016, the morning after last year's Diwali celebrations, the Indian city of Delhi was encompassed in a huge bubble of smog. This picture is actually not in Delhi, but in another of the cities, Indian cities. It was a bubble of smog made up largely of tiny particles and droplets of carbon, which are classified as something called PM 2.5. So they're tiny particles, very tiny particles, less than 2.5 microns in diameter, 2.5 millionths of a metre in diameter. And they're in concentrations in the atmosphere sufficiently high to cause eye and throat irritation and to get into human lungs and actually to enter bloodstreams. So very high levels. In this particular instance, the wind was slowing after the end of the monsoon, and the firework residue, as you see here, was added to the normal atmospheric load of car exhaust, road dust, smoke from open fires, and so on. And the US Embassy has a monitor for PM 2.5, this fine dust, and it recorded a figure of 9999 micrograms per cubic metre. Now, to me, actually, I think probably the instrument was at the top of what it could record, because the safe legal limit for India is 60, and this was 9,999. Now, that sounds bad, but keep that figure of 60 in mind, because the same day, on an air quality monitor in Farringdon, which is only 500 metres from where we are, recorded a PM 2.5 figure of 139 milligrams per litre. So the Indian legal limit was 60, and we had 139 milligrams per cubic metre at Farringdon. I'm going to come back to London in a few minutes, metaphorically. Some of these smoke-related air pollution episodes are so large and so intense that they're visible from space. Research by NASA in the second half of 1997, this is quite old now, showed particles from the burning Indonesian trees and peat remaining stagnant over Southeast Asia. So this is the white area here. So this is smoke stagnant over, I think it's Sumatra, more or less there. While low-level ozone, also a contaminant being generated in that area, spread more quickly westwards across the Indian Ocean. So the yellow and green is the ozone is spreading in a different direction because it's moving westward in the stratosphere. Now, ozone is toxic to humans. Ozone is toxic to humans. So although it has benefits in the stratosphere in stopping radiation, it's toxic at lower levels in the atmosphere. And the point here is that these very intricate atmospheric circulation patterns are responsible for shifting and dispersing these contaminants around. But they're also, I think it's worth remembering that if we want to understand what happens in the future, we're going to need to build climate change into this, because one of the things that influence this pattern is the timing of El Niño, particular ocean warming and cooling events, which alter the date at which the wet season starts and the fires are damped down. So if the wet season starts later, you get worse problems with air pollution in places like Indonesia. So the science of that, the meteorology and the long-term issues are quite complex. Now I'm going to show you a little video now about an invisible contaminant. So like low-level ozone, which is actually invisible, one of the big challenges for us now is nitrogen dioxide. And I'm going to show you a little video about nitrogen dioxide, again from NASA.
Nitrogen dioxide is a gas emitted during the combustion of fossil fuels. It's released from the tailpipes of cars and the smokestacks of power plants. Together, these emissions affect the quality of air we breathe. Since 2004, an instrument aboard NASA's Aura satellite has measured levels of nitrogen dioxide in Earth's atmosphere. In 2014, we released satellite images that show how environmental regulations have led to reductions in nitrogen dioxide over major U.S. cities. Now we created global maps that allow us to see how levels have changed around the world over the last decade. In Western Europe, despite the recent vehicle emissions scandal, nitrogen dioxide levels have decreased by as much as 50% due to tighter environmental controls. In China, we see an increase in levels over most of the country due to a rise in coal use for power generation, but decreases for some cities like Beijing, where a growing middle class is now demanding cleaner air. In the Middle East, we see decreases in nitrogen dioxide levels over Syria due to the country's civil war and displacement of its population. Meanwhile, levels have gone up in neighboring countries where millions of Syrians have taken refuge. In the U.S., the only increases are in regions with intensive oil and natural gas extraction, including fracking. In North Dakota and Texas, we see increases of 30% in some areas. By monitoring levels of nitrogen dioxide from space, we can see and quantify the effects of things like energy usage, environmental policy, and even civil unrest on air quality across the globe.
I can't help thinking, actually, that NASA might regret some of the statements there about the implications of changes in nitrogen dioxide and the links between fossil fuel extraction, given incoming President Trump's personal and family interests in promoting fossil fuel, and the fact that NASA is very reliant on public funding. I rather imagine we won't be seeing that kind of video again. However, so there we have nitrogen dioxide, very quick illustration. If we turn to China, for example, that was picked up in the film there, they get not only this chronic level of nitrogen dioxide and other pollutants like fine particles, but they get acute incidents too. So in the last couple of months, actually, there was a red alert at the end of December in 2016, last year, which prompted the closure of factories in many northern Chinese cities and the grounding of flights and limits on the number of cars to try and reduce pollution in what, clearly from the photographs here, they are Daily Mail photographs actually, is pretty shocking, and this one is even worse perhaps. And any of you that have stayed in high-rise in China, as I have, may have seen this kind of thing. If you stay on a high floor in a hotel, you can't see the ground because there's a kind of yellow soup underneath you. So that's a typical sort of situation for many megacities in the developing world, and whether or not the atmospheric pollution is actually visible, and though often it is, and nitrogen dioxide, I think if you look at the previous sort of slight yellowish tone, that's the nitrogen dioxide. In the case of China, though, that influence, that effect, is almost certainly a partial function of the inextricable economic links between nations. So the West, including the UK, we have effectively exported some of the worst excesses of our air pollution to manufacturing-intensive nations such as China, India and Thailand. So we, in the West, are not only responsible for our own pollution locally, but we're also partly responsible, by virtue of the things that we buy, for the damage created elsewhere. Now let's have a look at some of those global patterns. Globally, we see, I would say, largely explicable patterns of air pollution. The maps here show the map here shows some of the worst affected cities and regions for various air pollution parameters. This one here is particles PM10, so it's particles that are finer than 10 microns. Not the finest particles, it's the next group up. And based on analysis that was done by the World Health Organization. So these are fine dust and smoke particles which float in the air and reduce visibility. Now, some particles are naturally generated, so they come from desert dust, from natural fires and volcanoes, and actually as crystals of sea salt from the ocean. The 2016 figures, though, published by the World Health Organization, showed that more than 80% of the people who lived in the 3,000 reporting urban areas are exposed to pollutant levels exceeding the World Health Organization safe limits. So that's 80% of the people in some of our biggest cities are living in areas that exceed the World Health Organization defined safe limits. We also can see that while all the regions of the world are affected, populations in low-income cities are the most impacted. You can probably just about see here if you look at the comparative figures, so for people who living in poor countries, low and middle income countries, 95% of the people in the cities are affected, whereas in areas such as Great Britain or Europe, it's only 56% of the people affected. So there's quite a big difference. So a vast swathe of the earth, in fact, from China through the Far East, India and the Middle East, has excessive levels of PM10, those airborne particulates. And there are hotspot outliers, of course, too. Just go back a minute. There's outliers in places like Nigeria, here, and isolated places in South America and Central America as well. Onitsha in Nigeria has the dubious honour of being the most polluted city, as you see from the ranking here. Of course, what we need to remember is that those maps and listings show only the 103 countries that do routinely monitor and publish air pollution data. And interestingly, Nigeria does, whereas Russia, by and large, does not. PM 2.5, the very smallest particles, finer and lighter and more susceptible to being inhaled and more susceptible to generating lung problems, including cancers, are shown on the diagram here. And here you can see the swathe of largely, not entirely, but largely poor countries that are experiencing some of the highest levels in Bangladesh, for example, over here in Dhaka. And it's incomplete combustion in engines, it's power plants and industrial premises and open cooking fires. So, no surprises there. Here we can see a diagram that's trying to represent here two parameters at the same time. So what we've got in the sort of yellow-red range is the finest dust, PM 2.5, where you can see that quite a lot of southeast England, or quite a lot of England in general, is actually affected this, or it was in 2012. The next level up, the next largest dust, is reflected in how dark the colour is, from sort of white, light through to black. And there you can see those coarser, slightly coarser materials, that large large Asian and African swathe of countries. So in Britain, it's red, it's the finest particles, not the next step up, not the slightly coarser ones that are the problem. London, in fact, is the only UK city where the daily limit value for the finest dust set by the World Health Organization is regularly exceeded. And again, it's exhaust fumes from diesel traffic, at least as far as we understand it from the monitoring and the modelling. Now, if we turn, by contrast, to nitrogen dioxide, invisible, again, we've got a problem in the UK. The United Kingdom fares rather worse than many other European areas, and the pollution limits set by the EU for 2012 are periodically exceeded in 11 cities in England and Scotland. So Aberdeen, Glasgow, Liverpool, Bristol, Manchester, Birmingham, Oxford and London all have daily averages over the EU limit. And there's only very limited sign of a significant reduction in the average over the last 10 years as well. So we may have stopped the sulfur dioxide problem, and we've stopped our ancient monuments being continually washed with sulfuric acid, but we haven't stopped ourselves breathing nitrogen dioxide. As I said, London remains one of the most polluted city centres. We've got different ways of modelling, atmospheric modelling at regional and local scale. I'll just put up an example here of how this is done, or what the output looks like for part of Western Europe. But I want to draw our attention and stick to London for a minute. The King's College London researchers run something called the London Air Quality Monitoring Network. And this year, the network, and this was widely reported in the press, they found that Brixton Road breached the EU annual air pollution limit by January the 5th. 12th night, I think that is, isn't it? EU law states that the average hourly level of nitrogen dioxide must not exceed 200 milligrams per cubic metre more than 18 times a year. Okay, so you're allowed 18 spikes because of the weather variation. But Brixton Road had 19 spikes by January the 5th this year. And at one point, those levels were nearly double the legal limit. And you get a similar pollution problem as along many of London's main roads. Now, I'm going to show you this little visualisation from. You can find it yourself on the net, on the web. You can see here's the Shard. Somewhere over here, let's see it now. Somewhere over. Oh yeah, there's the London Eye. We're actually about here. So don't breathe too heavily on your way home, I would suggest. It's not looking good. And you can see that this kind of modelling at really detailed level, at street level almost, is becoming really very effective indeed at representing the situation. We've got pollution problems here in Oxford Street, King's Road, the Strand, and so on. And allegedly, if you believe this model, and it is only a model, Oxford Street has the worst nitrogen dioxide pollution in the world. So, interesting visualisations. Urban air pollution, then, is a challenge almost everywhere in the world. Now, I want to turn my attention to the question of whether it really matters. I think it does. The cost of air pollution is absolutely staggering. Now, as we go through this, it's going to become apparent that there are different figures being published in different locations for the cost of air pollution. The World Bank estimated the cost of lost work days and social costs at $5.4 trillion a year. $1 trillion a year. That's a lot, obviously. In 2016, they suggested that the direct cost to the global economy, actually that's how you identify the direct cost rather than the social and health-related costs as well, was $225 billion. But more importantly than that, in places like China and India, both of which we saw with those lots of red colours on them, they're losing about 8 to 10% of their GDP as a result of the cost of sorting out and responding to air pollution problems. The figure for the UK is allegedly something like £5.6 billion a year. We're spending £5.6 billion a year trying to sort out the implications of air pollution, even though we've exported some of it, as I indicated earlier. So I'll just pause for a minute there. $5.4 trillion a year. Now, you might say that that's an act of collective insanity, and that's, again, a phrase I might come back to in a minute. I do think, though, even those figures may be underestimates, because the services that the environment provides that are dependent upon a good quality atmosphere also need to be considered. Farming and horticulture are good examples. If you have dust falling on crops, it reduces their growth rates and it reduces their value when they're sold. The diagram here, which has the names of some complex chemicals on it, is related to research on bees. Now, what has recently been established is that bees are influenced by air pollution, and the research has been done by Penn State University in America, because the pollution overwhelms the smell of the flowers, the scent of the flowers, so they can no longer detect the plumes of scent coming from flowers, or sometimes the scent have been actually altered by chemical reactions with ozone, for example, and other pollutants. And when they're foraging for crops, they can't find the crops. They're foraging for food. They can't find the food sources. And so they bring less back to the hive. So for crops where insect pollination is important, leaving aside the honey, this is a vital ecosystem service which is diminished, and it has a lot of value. So what we've got in this diagram here is two different chemicals. Again, we won't worry too much about them, but it's showing you the effects of increasing... so this is the scent plume in coming downstream, so it's going downwind there from left to right. This is the scent plume in an area that's got a small amount of air pollution. And when you get down here, the scent plume is disappearing because it's being overwhelmed and actually, in this case, absorbed by the chemicals. And in this particular pollutant, this particular scent, the pollution is almost removing the plume altogether. So the cost of that, the cost of reduced bee pollination, is very considerable. So what I'm saying is, if we factor in the cost of that, the ecosystem services, the air pollution has reduced the natural capital of the Earth and diminished its value in a way that's really astonishingly large. It might be possible, and the UK has been something of a leader in this, it might be possible to put an actual value on some of those ecosystem services, and doing that may, it's supposed, it may draw it to people's attention. We have a very pioneering group, the National Ecosystem Assessment Group, that published their assessment for in 2011 in the UK. It's one of the most comprehensive reviews of the state of the natural environment in any country in the world and of the value of ecosystem services. But other people have alleged that it's dangerous to do this, to publish the value of things like bee pollination, because if you say, well, this is worth so much, then an industrial concern might say, oh, well, we'll pay that and we'll actually trade it because we'll plant some forest somewhere else, which is worth this amount. So trading one parameter, the value of one parameter, against doing something positive on another parameter, that's all right unless everybody opts out of improving air pollution and says we'll plant forest because the forest will die because of the air pollution, even if the economics is sound. At European level, it's been suggested that pollution costs about €1 trillion a year in healthcare and in dealing with the wider impacts on ecosystems. I should add, and this is again a figures that's been much debated, it is the European Environment Agency Executive Director who made this statement. She added that pollution on average is reducing life expectancy by about 8 months across European cities, and in some areas it is as much as 22 months. So people are losing almost 2 years off their life. And I might ask you to think where London is in that range, whether it's closer to 8 months or 22 months. We've known about those adverse implications for health for a long time. Certainly since the 1990s, people have known about fine dust, and research, despite the effects or the efforts of some of the industrial stakeholders, United States research that identified these health impacts was picked up in Europe and used to inform policy development. So we know what the health implications are. We can see, in some cases, what air pollution does to lungs. Look away if you don't like medical pictures for a minute. The lung on the right is a Delhi resident, which you can see it's blackened by the smoke inhalation. Somebody who lives on the streets in Delhi and breathes cooking smoke. But if you go back to things that are more apparent to us in the UK, we can see that health implications include heart diseases, lung and respiratory diseases such as bronchitis and asthma, strokes, cancers. All of those are well documented by research evidence. The latest thing to have cropped up in the press, and you may have seen this just before Christmas, was suggestions of implications for dementia. And that people are now saying, or Canadian researchers in particular, are saying as much as 11% of dementia cases are associated with fine particles, perhaps of iron compounds, close to main roads. So dementia is higher if you live within 50 metres of a main road and falls away as you get further away. So that we don't know why, we don't understand the brain pathology. They weren't able to suggest how that worked. But it's nevertheless likely to be true. It's also been suggested, again, as a result of residence and school achievement, that there is a loss of ability to concentrate amongst school children and others. But I flag this one up because this is a good example where demonstrating causality is extremely difficult. Poorer people tend to live closer to main roads. Children have less opportunity and may achieve less well in school because of the lack of opportunity rather than the implications of the atmospheric pollution. So we don't know in some of those cases. Sticking with London and the UK, for example, we know that the UK probably generates something like, or air pollution in the UK generates something like 29,000 early deaths per year across the UK. And 4,000 of those are in London. There was a 2010 study, actually, which suggested that the association with that very fine dust, those PM2.5s, was the equivalent of 3,389 people dying as a result of air pollution. Now, that's a larger number than typically die on our roads, I think, actually. But we do next to nothing about it. And we argue, for example, about the variation in the weather and whether it's 3,900 and 3,800 and whatever it was, or 4,000, and whether the figure is actually going up or down, or whether it's worse in Bromley or Westminster. In fact, it's almost stable for the last few years, those figures. And it's appalling, and that bold measures appear to be called for. Elsewhere in the UK it's similar, so London, Birmingham and Leeds, for example, have just been subject of a recent ruling by the Supreme Court because they're unlikely to meet nitrogen dioxide EU limits until after 2030. And that's not good enough. Now, to my mind, improving air quality depends first and foremost on understanding the science. So I want to look at a few solutions. We need to understand the science, of course, and thereafter we need to have the economic power and the political will to address the challenges, and I'll turn to those in a minute. But the science of air pollution is tough enough to handle. We've seen that. Different chemicals may react with one another to generate what's often called photochemical smog, and the range of contaminants involved is huge. There's some research at Lancaster University, for example, on a whole range of target chemicals, which I'm not even going to try to pronounce, but which we haven't talked about particularly, generally classified as polycyclic aromatic hydrocarbons, and there's a bit more about them in the transcript of the lecture. But they've been monitoring those since 2010 and generating long-term air trend data, which is good, but we don't actually really know where they're coming from. And we also know that air quality is influenced not only by the emissions themselves, but from point sources or more widely dispersed ones such as agriculture, but we know that things like weather, temperature, wind speed, turbulence, the design of urban areas, if you've got canyons, for example, in the urban area, or open spaces, and the monitoring technology itself, they're all fraught with difficulty. What do you sample? When? Where? For how long? Those are really crucial questions. And modelling air quality, that visualisation I showed you, is a model. It's based on a set of point observations, but it's nevertheless a model. And of course, if we model, we measure and we model, that's not a solution. That's just enabling us to understand what the problem is. It may enable us to make a response, perhaps even in real time, but it's mainly a sort of palliative exercise because we've got to stop the emissions at the source, not just disperse them. Now, there have been some truly extraordinary technological solutions. I love this one. This is a tower, a movable tower in China, a smog-free tower, and they tour it around, and it pulls in airborne particles electrostatically. And apparently, also, actually, they compress them into small cubes, and they use them to create jewellery, it said. Also, on the press release, it said each cube is said to contain 1,000 cubic metres of particles, and they set them in a ring, so you can have a souvenir of clean air. Now, if you believe that, you'll believe anything, I think. But apparently in Beijing, they've already made 300 of them. I don't know whether they've sold them. But the point about this is not a sustainable solution because it relies on an electrical power supply powered in the main by, anybody like to guess? Coal-fired power stations. Yep. Here's another one. This is a roof-mounted vacuum cleaner that's been sitting on buildings in Amsterdam, trialled in Amsterdam. It's supposed to pull in air from up to 7 kilometres above it. Again, if you believe that, you'll believe anything. But these devices rely on somebody paying for them and for the running costs, and I have no idea whether they are effective, but then I think they are rich people's playthings. Now, if you turn on rather less problematically, if you turn on your mobile phone today in London, you'll find a whole series of apps that offer you interactive and real-time information on air quality problems in London streets, and so you can avoid the hotspots. It's free, lots of apps. In fact, I think it's even on Google Maps, if you look on that. Cyclists and pedestrians in particular can modify their journeys to minimise the risk of an asthma attack or a sore throat. And again, King's College London are pioneers here. It's based on, their app is based on the hourly readings at monitoring stations across the conurbation. There are about 120 of them in Britain. And of course, I suppose in due course, those observations might start to influence house prices, which would be interesting. In addition to that, Lord Drayson has a company called Drayson Technologies, and it's selling a £75 tag that you wear around your neck, and it measures carbon monoxide, and it syncs with your phone on an app called Clean Space, which is the one on here, and it shows you what your exposure has been on any particular journey, and it also gives you rewards, apparently, like cups of coffee, and it's generating massive amounts of data. So the direct intention is to influence people to avoid the pollution. But perhaps the longer-term implication is that by raising public awareness, you might start to bring pressure on the legislators. Now, of course, if you're wealthy, you can buy a house in an area that has generally better air quality. Think about those top-floor flats in those Chinese skyscrapers. There's plenty of evidence amongst rich Chinese urbanites, the subject of research, that they are doing just that to avoid the problem. And they also spend a lot of money on room air filters, particularly when there are peak pollution incidents, particulate pollution incidents, notified by the Chinese Ministry of Environmental Protection. So they wealthy people buy masks like this for their children online, whereas poorer people buy largely ineffective paper masks. So there's a real polarising phenomenon here, a real life inequality issue at local and national levels. Machines that filter the atmosphere, internally or externally, and the adoption of personal protection measures and the avoidance of the most highly toxic environments are not, of course, sustainable solutions for this problem at all. And it seems most likely that reductions of emission at source, backed by monitoring and modelling, and then mandated by legislation, are the only thing that really works. Now, why isn't it working? Well, if we look at the UK for a minute, air quality management legislation was passed first in 1273, apparently, in London. Coal burning was banned in 1306, and then obviously that must have been forgotten, and periodically it was banned again. But it wasn't until the Clean Air Acts of 1956 and 1968 allowed, local authorities to put smoke control areas in towns where only clean fossil fuels could be burnt, that things really started to shift. And of course, not all local authorities did do that. Some authorities were concerned about the cost for local industries and didn't pass the legislation at all in their areas, or they phased it in, starting with the bits that were upwind of their own city, regardless of the downstream or downwind impacts outside their area. we can start to see, I suppose, a little bit of the implications of the legislation coming around here in the 1990s, where some of these parameters do start to take a downturn. This is starting with a value of 100 for 1970 for different parameters. So nitrogen oxides in purple there did seem to take something of a downward turn from about 1990 onwards. That's been followed up by European legislation, and again I'm not going to go through all the details of this because it's actually not very exciting, but gradually there's been more and more parameters introduced. It's been tightening up. We've had an air quality strategy in 1997 produced by government, and we've continued to add more parameters and tighten the limits in Europe. It's based on scientific understanding, and it's largely driven in the UK by the European Union. Now, that's only largely advisory, and in some cases, of course, there's still a continuing debate about the complexity and the relationship between British legislation and EU legislation, and some people have said too that the limits are too high, so it's too easy to achieve the limits. Despite that, of course, the UK is frequently in breach of the standards, and some people in the UK say, as a consequence, oh well, that's because of the confusion between the UK and the EU, so it provides kind of ammunition, if you like, for the sceptical. Again, there's lots of EU regulation on vehicle emissions. Catalytic converters, of course, mostly we will be familiar with, and they reduce the relevant emissions by 90%, allegedly, in comparison with uncontrolled vehicles. Now, of course, again, if, like me, you own an Audi, you'll be very aware of the recent scandal in the case of Volkswagen, who were accused of, a charitable view would be that they had been tampering with their test results. In fact, as of, I think it was the day before yesterday, they were found guilty of a criminal charge in the US and fined some billions of dollars. So I can say it's not just me saying this is actually true, and I'm not likely to be sued, or Gresham isn't likely to be sued as a result of me saying so. But those test cycles are not very good at mimicking realistic driving. Now, I'll skip that one. Now, key issues for the UK, we've already covered some of these. We have still, despite all the legislation, despite all the research, major problems in the UK. We have the sort of issues that are on this. We know we know where the problems are. We know something about the origins of those problems. We know the health implications. We know the figures on deaths. They've been confirmed by numerous studies by all sorts of researchers. Why isn't there more public protest? I've got an endless supply of pictures of protesters with ridiculous signs. This one's got nothing to do with air pollution at all, but I just like it. What do we want? Time travel. When do we want it? It's irrelevant. But why aren't there more protests about air pollution in London? Why aren't I? Well, I don't live in London, but many of you do. Why aren't you out on the streets protesting? It's freezing. It's an interesting question. A whole lot of things start to appear as possible reasons. And again, we can't go through all of them. We've got possibilities like perhaps the public is ignorant and they don't understand the risks, or they think the experts have got contradictory views, or perhaps they don't believe the experts. We know experts are no good now, so the science is wrong. Or you suspend disbelief because it's inconvenient. You actually like driving your car, so you choose to believe something other. Or we're misled. Or we hold two contradictory opinions at the same time. Or we think we've got no power, or it's all too expensive. Or, as I said at the bottom, some kind of collective insanity. I took this from views published from the Institution of Environmental Sciences journal a couple of years ago it was EU Year of Air, I think it was, 2013. And so got just 5 statements here from different people on what they think the problem is and what they think the solution might be. And they're all different. Could be any of these things, of course, any of these things. If we look at, again, we don't have time to go through all of these in detail, but we could look at the psychology of it, and we know that from research that people's individual psychology and their experiences affects what they think about air pollution. This was research done in Greece, actually, and it showed that things like the weather actually affected what people thought about air pollution, not just the experience that was actually going on, but what they thought about it. So these are significant challenges. What we end up with summarising is to say that this air pollution is another wicked problem. Now, those of you who have been to previous lectures will have heard me talk about this before. Wicked problems have particular characteristics. And from what I've said this evening, I hope you can see that many of those are reflected in this research by Rittle and Webber from a long time ago now, the 1970s. So the problems are not very well formulated, they're complex, we've got physical, scientific and human dimensions. What happens in one place and time affects what may happen somewhere else at a different time, even in another country. There's lots of different stakeholders. There's car manufacturers, lawyers, scientists, shopkeepers, you and I, and so on. We don't agree about what's important, and we use terminology in different ways. Less of a problem, I think, for air pollution, that one. But we can't agree if the problem's been solved or how to address it. Now, these are all characteristics of what are called wicked problems. And there are ways of tackling wicked problems which have not been tried to any significant extent. We know, for example, that if you present information graphically in imagery or graphs or pictures, people are much more likely to assimilate it. We also know that more curious people, more scientifically curious people, are more likely to be accurate or more likely to be accurate in what they believe in the way it relates to reality. There's some quite complicated research on this, which is interesting, actually, that says that scientifically curious people are more likely to seek out contrary views to those that they hold themselves. And they say, for example, if you study climate change and fracking, people who have a scientific background and are curious, it's the curiosity that's the important thing, they're more likely to actually explore the issue thoroughly and have some proper understanding. And it would be nice to think that those phone apps might start to stimulate some curiosity from people who are cycling through some of those red peaks on the map. Now, I want to end up by saying London is a real problem. It's not one of the cities that signed up to the new pledge to ban diesel cars from congestion zones by 2020. We are pretty good at the science in the UK, but we're pretty bad at the implementation. Government has put in a certain amount of money. Again, I won't go through all of this, but we might just note that there are 9,500 premature deaths in London related to air pollution on one estimate, and the amount of money that's been allocated to sort this out is £22,000 per scheduled death. And that's actually not very much, is it? So perhaps we could say it's not just collective insanity, it's collective suicide. And we might start also to think about what's the implications if we haven't got the EU there to develop some of this air pollution legislation, make sure it's enforced, because we are exporting some of ours to Europe. And in certain weather conditions, we're importing it from Europe. So we need this transboundary agreement. Now, £22,000 per scheduled death. I talked about collective insanity. I'm going to finish the talk today by listening to Tom Lehrer.
If you visit American City, you will find it very pretty. Just two things of which you must beware. Don't drink the water and don't breathe the air. Pollution, pollution, they got smog and sewage and mud. Turn on your tap and get hot and cold running crud. See the The halibuts and the sturgeons are being wiped out by detergents. Fish gotta swim and birds gotta fly, but they don't last long if they try. Pollution, pollution, you can use the latest toothpaste and then rinse your mouth with industrial waste. Just go out for a breath of air, and you'll be ready for Medicare. The city streets are really quite a thrill. If the hoods don't get you, the monoxide will. Pollution, pollution, wear a gas mask and a veil. Then you can breathe, long as you don't inhale. Lots of things there that you can drink, but stay away from the kitchen sink. The breakfast garbage that you throw into the bay, they drink at lunch in San Jose. So go to the city, see the crazy people there, like lambs to the slaughter. They're drinking the water and breathing the air.
Thank you very much, ladies and gentlemen.